Okay, so this is the next lesson in geometry. It's called Isosceles and Equilateral Triangles. Okay, so its first definition is an isosceles triangle is a triangle with at least two sides congruent. Now, some people will say isosceles triangles have to have exactly two sides congruent, and some people say at least two sides congruent, so I just put that one, okay? They are very common in the real world. You can find them in structures such as buildings and bridges. The congruent sides of an isosceles triangle are called its legs. The third side is called the base. The two congruent sides form what's called the vertex angle. More on this in a minute. The other two angles are the base angles. So I have an isosceles triangle right here. So again, the congruent sides, like we said above, those are the legs. So let me just label that to show you what we just talked about. That's a leg, and that's a leg. Okay, the third side is called the base, so this will be my base. The two congruent sides form the vertex angle, so that is the vertex angle. And the other two angles are called base angles. So that's a base angle, and this is a base angle. Okay, so the two congruent sides are called the legs. The other side is called the base. The angle formed, or the included angle between the two legs, is called the vertex angle, and the other two angles are called base angles. Now, there's two major theorems you have to know, okay? There's the isosceles triangle theorem, and there's the converse of the isosceles triangle theorem, okay? So remember, the converse is when you switch around the hypothesis and the conclusion, okay? So let's start with the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if you knew that segment AB is congruent to segment AC, then you can conclude that the two angles opposite them are congruent. So you can conclude that angle B is congruent to angle C. Okay? So again, if two sides are congruent, then the angles opposite those sides are congruent. And the converse is also true. If you know two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if you knew that angle E was congruent to angle F, then you can conclude that segment DE is congruent to segment DF. Okay? You have to know those two theorems. Now, one of the reasons why I like geometry is because you can see why stuff is true. So I'm going to show you why the isosceles triangle theorem is true. In other words, I'm going to prove that theorem that I just showed you. Okay? I'm actually going to prove it. So given that segment AB is congruent to segment CB, prove that angle A is congruent to angle C. Start with my givens. Proof is going to be 6 steps. Okay, so after I do this proof, I will have proved the isosceles triangle theorem I just showed you on the previous page. I want to prove it, so I can't use that in my proof. I have to use other information. This is kind of a weird proof, but here's what I'm going to do next. This is really quirky, but I'm going to draw in XB. And I'm going to draw in XB such that it is the bisector of angle B. And that reason was by construction. I just constructed that myself. Like I said, this is a quirky proof. I'm going to do that by construction. So I just drew in XB, the bisector of angle B. Since it's the bisector, that means it cuts angle B in half. So this angle is congruent to this angle. So I'm going to say for my next statement, angle ABX is congruent to angle CBX. Whenever there's not a theorem name or a property name, it's going to be definition of. That is a definition of angle bisector. Here's what I'm going to say next. I'm going to say that segment BX is congruent to segment BX. Reflexive property of congruence. And now check this out. We have the triangle on the left congruent to the triangle on the right because of side, angle, side, side, angle, side. So, triangle ABX is congruent to triangle CBX by side, angle, side. And now, since I have the triangles congruent, I can say that angle A is congruent to angle C because corresponding parts of congruent triangles are congruent. CP/CTC. So again, that was a weird proof, but I think it's really useful because that shows you why the theorem on the previous page is true. Okay? So since I know that side AB is congruent to side CB, I can say that angle A is congruent to angle C. And that's the reason why. This proof right here just showed you why. I think that's kind of useful. I like that about geometry. Now let's do some examples. Find the measure of angle F. So we have an isosceles triangle. I like saying the word isosceles. Isosceles. So this side is congruent to that side. So it means that this angle is congruent to that angle. Because if two sides are congruent, then the angles opposite them are congruent. I think we've done problems like this in the past. So we do 180 minus 22 equals 158. And each of these are the same. So if I do 158 divided by 2, it gives me 79 degrees. So let's write that the proper way. The measure of angle F equals 79 degrees. Find the measure of angle G. Well, this side is congruent to that side, so it means the angles opposite them are congruent. So angle G is congruent to angle J. So it means that their measures are equal. So I'm going to say 3x equals x plus 44. Solve that for x. 2x equals 44. X equals 22. Now that's great, but make sure you answer the question. The question did not say find x. The question said find the measure of angle G. So the measure of angle G equals x plus 44. So it equals 22 plus 44. So it equals 66 degrees. And if you want to double check, because it's not a bad idea, check the measure of angle J. That equals 3 times x, so 3 times 22 also gives you 66. And let's pretend I said find the measure of angle H. Well, all the angles add to 180. So if that's 66 and that's 66, you would do 180 minus 132, because that's what you get when you add them together. And you would get the measure of angle H equals 48 degrees, if I asked you for that. Okay, let's try example 4 next. Find AM. Interesting. So this one has a little trick to it. Okay. Give me 1 second. 7 times 7. Oh, yeah, that's fine. Okay, so again, there's a little bit of extra information in this diagram. Okay, what you need to know is that this angle is congruent to this angle. So the sides opposite those angles are congruent. So this side, SM, is congruent to this side, AM. Ignore the other side. That's just extra information. This side is congruent to this side because these two angles are congruent. So what I'm going to do is I'm going to do 6x minus 9 equals 4x plus 5. And solve that for x. 2x minus 9 equals 5. 2x equals 14. X equals 7. Now let's find AM. AM equals 6x minus 9. So AM equals 6 times 7 minus 9. So 42 minus 9, which gives you 33. Now also notice how I'm writing the answer. Think back to Unit 1. You do not put the bar above AM when you say AM equals a certain number. So no segment bar above AM. And if you want to double check your answer, double check SM. Don't double check SA because that's not the same as AM and SM. But if AM is 33, SM should also be 33. So 4 times X, 4 times 7 is 28, plus 5 is 33. So that works. Good. I love this problem right here. Example 5. This is the type of question that you could see on like SATs. If GH is congruent to HK and HJ is congruent to JK and the measure angle GJK equals 100 degrees, what is the measure of angle HGK? Oof, okay, so let's label. GH is congruent to HK and HJ is congruent to JK. What is the measure of angle HGK? GJK is 100, so let's label that. GJK is right there. Okay, so if that's 100, let's find these two angles with the stars. Those two angles that I just labeled with the stars, they are congruent because this side, HJ, is congruent to this side, JK. So since these two sides are congruent, the angles opposite them are congruent. So those angles I labeled with the stars, they're congruent. Now you might be able to figure them out in your head. If not, do 180 minus 100, that gives you 80. And 80 divided by 2 gives you 40. So each of those angles that I labeled with stars is 40. So let me label that now. 40, 40. Now let's find this angle with the star, GHK. You know what that angle is? You have a linear pair right there, so 180 minus 40 is 140. So this angle is 140. And now we can find the final two angles in that triangle because, and again, you might be able to do this in your head. If not, you're going to do 180 minus 140 equals 40. Because this angle is congruent to this angle, because GH is congruent to HK. So 40 divided by 2 gives you 20. So this angle is 20, and this angle is 20. So the final answer, the measure of angle HGK equals 20 degrees. Last page. An equilateral triangle is a triangle with all three sides of equal length. It is therefore a special case of an isosceles triangle having not just two, but all three sides equal. And since all three sides are equal, all the angles are equal. It's like an extension of the isosceles triangle theorem. So if each angle is the same, and then all three angles add to 180, then each angle has a measure of 180 divided by 3, which is 60 degrees. So example 6, find x. Each angle is 60 degrees, remember. Since each side is the same, it means that each angle is the same. So this angle is congruent to this angle, or just congruent to this angle. So each angle is 60. So 2x plus 32 equals 60. 2x equals 28. X equals 14. And our last problem. Triangle EFG is equilateral and EH bisects angle E. Find the measure of angle 1, the measure of angle 2, and x. Okay. So, since triangle EFG is equilateral, it means each angle is 60. So this is 60. This is 60. And this entire angle up here is also 60. But it's bisected. It tells you that EH bisects angle E. So angle 1 is congruent to angle 2. And since all of angle E is 60, each part is going to be 30. So I'm going to say the measure of angle 1 equals 30 degrees, half of 60. And I'm going to say that the measure of angle 2 equals 30 degrees, which is half of 60. Because remember, all of angle E is 60 because it's equilateral. So 60, 60, and this entire angle is 60, but it's bisected, so each part is 30. And now to find x, let's focus on this small triangle on the left. And you know what, I'll just label this as 30. And I'll label this as 30. With that small triangle on the left, all the angles add to 180. So, triangle angle sum theorem. So what we have is we have 15x plus 60 plus 30 equals 180. Triangle angle sum theorem. Okay? So 15x plus 90 equals 180. Keep going, solve for x. 15x equals 90, which gives you x equals 6. Okay? And that is the end of that lesson. That lesson was called Isosceles and Equilateral Triangles.